The Chinese are serious while the National Space Administration of China has been completing one successful lunar mission after another for several years. It's also celebrating new milestones as part of the Chinese lunar program. Two probes have already been brought to the far side of our satellite, and a few months ago, the next big step followed. In June of this year, Chang'e 6 actually became the first probe ever to bring a rock sample from the mysterious far side of the moon to Earth. And although China has now made space history several times over, the successes to date were just the beginning. The bottom line is that the ambitious program aims to bring people back to the moon by 2030 and in the future, even to build a permanently manned moon base. According to Michio Kaku, however, the lunar medal also has a pitch-black downside. The international space agencies are currently in the process of sliding into a bitter fight over the division of the moon. The starting signal for the second race into space has been given, and while the USA was ultimately able to clearly win the first space race against the Soviet Union, these days, they seem to have fallen behind the Chinese. As mentioned at the beginning, the Chinese lunar program to date resembles a celebrated intoxication, which reached its latest peak on June 25, 2024. In fact, this was the day on which the sealed capsule of the Chang'e 6 mission landed in the steppes of Inner Mongolia and thus once again immortalized itself in the astronomical history books. After all, the capsule returned to Earth with almost 2 kilograms of rock samples from the far side of the moon, enabling experts on Earth to directly examine the material composition of this hidden area for the first time ever. Furthermore, the unprecedented sample could also help to crack some fundamental mysteries about the development of our constant companion. Because there is one thing we must not forget. Despite all the Apollo programs and subsequent research missions, the far side of our satellite has still hardly been explored. Specifically, no Apollo crew ever landed in this Earth-facing area, and the later soft, that is, unmanned, moon landings also mainly focused on those regions that shine at us from the sky on clear full moon nights. And so it came to pass that it ultimately took until 2019 for humankind to finally bring one of its technical outposts to the far side of the moon. After the Chinese probe Chang'e 4 had touched down there, it and its small rover granted us our first glimpse of the nature of the rock at the moon's south pole. But humanity would not be humanity if it were to simply rejoice collectively over the lunar milestones of its own kind. In fact, China's successes on the moon are also synonymous with the opening of a new competition between international space agencies. And when the question arose as to whether China's National Space Administration, or CNSA for short, could overtake NASA in the future, a certain Michio Kaku was consulted to give his assessment of the situation. As probably the most famous astronomical pop star of our time, the American theoretical physicist spoke to the U.S. channel Fox Business Network after the globally acclaimed return of the moon samples by Chang'e 6, and he was quoted as follows. China has been methodically copying the United States and the Russians for years, and in a few years, they could be competing with us to go back to the moon. In fact, some people think that by 2030, there could be land wars over the various regions of the moon. This is something we need to keep a very close eye on, the war for the moon properties. When asked whether the overarching goal was to establish a base at the moon's south pole, Kaku replied as follows. The Chinese have stated that they will bring their astronauts back to the moon by 2030. So by 2030, we should also start to have a permanent presence on the moon. This is not meant as a war, however, because a rocket takes about 3 days to reach the moon from Earth, so that's too long to wage a space war. But instead, there could be rival land claims, so-called property wars, when nations start dividing up the moon. In this context, Kaku also referred to the 1967 Outer Space Treaty, because the question of who owns which area on the moon is not a new one. The aim of the said treaty was to prevent the occupation of celestial bodies by individual nations. Instead, the use of outer space was subjected to purely peaceful purposes, and civilian space travel and space exploration were explicitly permitted to every state. As a result, neither nuclear weapons nor military bases may be placed in outer space. However, when it comes to the acquisition of property on the moon, the situation is far more complicated. According to Kaku, this is an open question that is not clearly regulated in the 1967 Outer Space Treaty. No wonder. After all, in the 1960s, the construction of stations on other celestial bodies still seemed extremely futuristic. But now that the corresponding future is fast approaching, we would be well advised to find an overarching solution to this point of contention. But aside from all these political squabbles, there is also the potential for scientific knowledge. But according to Kaku, it is unlikely, to say the least, that U.S. researchers will also get a glimpse of the moon samples collected by China. The reason why the relationship between the U.S. and China is, in this respect, not so cordial is that the Chinese Space Agency is closely linked to the military. In this context, it is therefore extremely difficult for the United States to share space secrets if they are immediately passed on to the Chinese military. What Chang'e 6 discovered on the moon. But why is the division of the moon so important? Well, the fact that our satellite has not only come to the attention of research teams, but also of states and large corporations is primarily because it resembles a cosmic treasure trove of raw materials. In detail, our faithful companion contains a wealth of resources that are either rare on our planet or are gradually running out. These include elements such as neodymium and yttrium, which are essential for the production of cell phones and electric cars. But titanium, aluminum, and silicon also exist in abundance on the moon. The same applies to helium-3, an isotope that is extremely rare on Earth and could one day play a crucial role in clean energy production through nuclear fusion. And although nuclear fusion is still in its infancy, experts believe that helium-3 has the potential to supply the Earth with energy for centuries and is worth an estimated $4 billion per ton. But if we now take our minds off the lunar raw material mining of the future and instead take a look at the findings of the present, we realize that, from a purely scientific point of view, these are no less valuable. After all, the samples collected by Chang'e 6 could also help us to crack the mystery of the different lunar hemispheres. While the moon always presents us with the same side due to its locked rotation, it also has two faces that could not be more different in terms of crust thickness, past volcanic activity, and composition. The Chang'e 6 samples could therefore hold the answer to the question of which geological processes are really responsible for the striking differences between the two halves of the moon. The side facing the Earth is not only characterized by a thin crust and the numerous maria, in other words, lowlands covered by solidified lava, but also by the fact that its rock contains an astonishingly high proportion of rare earth elements, potassium, phosphorus, and radioactive thorium. How this so-called creep terrain was formed and what triggered the volcanism on the near side of the moon is still hotly debated. While some researchers point to the tidal forces of the Earth, others consider it more likely that it was the result of a violent impact that also created the gigantic South Pole Aitken Basin. Aside from the hemispheric riddle, the sample analyses could also benefit the construction of lunar stations, because these would have to be built largely from the material available on the moon. How the regolith and the moon's rock can be converted into building material is already being tested in terrestrial research centers, as are the processes for extracting water, metals, and even oxygen. However, the bottom line is that Chang'e 6 turned out not only to be a diligent sample collector, but also a real stroke of luck for all particle researchers. The probe was also equipped with a detector developed by the ESA, the so-called negative ions at the lunar surface, or NILS for short. And as the name suggests, this component was specially designed to detect negative ions. And it finally succeeded in detecting them on the lunar surface for the first time. The reason for this becomes clear when we consider that the surface of the moon is virtually unprotected from cosmic radiation and solar wind. The incessant bombardment of particles, in turn, sets off electrochemical and photochemical reactions in the regolith, which, among other things, ionize molecules and atoms of the lunar material. In the past, space probes had already succeeded in detecting some of the ionized molecules in lunar orbit, but these were exclusively positively charged ions, which, compared to their negative counterparts, have a significantly longer lifespan and are therefore easier to detect. The discovery of negative ions on the lunar surface has opened a new window on a previously hidden component of the lunar plasma. According to experts, the corresponding observations can also help us to draw important conclusions about other celestial bodies without atmospheres. And if our channel Digital Discoveries has not yet been added to your subscription sphere, You're very welcome to change that now. Simply click the thumbs up and subscribe to never miss a new video from us again. We'll see you soon.